Hello reviewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about sea launch platform. So let's dive right into it. Now first, what is the problem with our current land structure that we have to deal with going into the sea? Well, rockets are big boomstick. Inherently, every rocket is just a controlled explosion. All of the rockets, every single one, including Falcon 9. So one thing you have to understand, if minor defect translates to big boom, you have to understand we have to create safety standards for that. What does that mean? That simply means large exclusion zone. What does that mean? That simply means you can't have any people living nearby. If you have a launch site, the very large area around it, it will be permanently isolated from common public. Basically, normal people won't go there and build houses or buildings or things of that nature. Now, what is the primary problem there? Assume, let's say in future we have rockets that are very stable. Like we do build buildings next to airports, then why can't we do that same thing with rockets? Inherently, the problem is the noise of these rocket engines. They are idiotically powerful, and they are so goddamn powerful that over time they can degrade any structure. You will build like, okay, this awesome building that I'm gonna build is gonna be like general public building. I'm talking not talking about military bunkers, but normal building you build is this is gonna be strong, this is gonna be awesome, and few rocket launches later it's like, why the heck whole foundation is cracked? Because of the sound pressures are too goddamn high. And just to make sure that sound pressure itself does not destroy everything around it, including the rocket itself, because it can bounce back from this basically bottom up, we have to use large amount of water to basically water sound suppression system, and it absorbs some of the sound. Now it does make rocket launch go from like, flat out destroy everything to like, okay, only cause minor damage to everything. So we have to use large amount of water, and very large amount of it. I mean, like, gallons are not a unit which can be used here. It's like too small for it. Now what do we have in sea? Water everywhere. So that's the one problem solved. You will never have to worry about water running out, and it's not like you need dilute water or you need fresh water. You can easily utilize seawater also. However, there is another benefit of that. Seas are inherently natural sound suppression systems. How do we know? We have tested nuclear warheads there. So we know for a like actual fact that if big boom happened there, we won't even hear it. So that's one thing. Another aspect, which is for a very good reason, for financial reasons and all that jazz, it's a natural exclusion. Nobody lives in the sea. Like, unless you're talking about very specifically some small island here or there and all that jazz, most places there is no issue with it. Like, basically that allows you freedom. Basically you can launch a rocket any direction. You just have to create a zone around your rocket launch, so that in case if it falls at this zone, it should burn up. Basically the rocket should be high enough and fast enough that if it falls back to earth, it should burn up. Now that part can easily line up on top of any populated area, because all satellites orbit. Inherently all rockets are going above basically populated places. It's just that while you are doing that, that's the whole requirement for the space agencies. Like, okay, if your rocket are gonna cross over a basically populated area, it must be high enough and it must be fast enough that if in case it falls down, it should burn up. Basically atmosphere should act as a good shield at that point in time. Now generally that means rocket does take time to pick up speed and get velocity. So you always have a launch zone that in such a way, like, just go away from populated places, and by the time you actually have enough velocity, you will be high enough where even if you are crossing basically Russia or USA or India, you don't have to worry about, because you will be high enough and fast enough that it atmosphere act as a good shield. C are in a very unique way allows you the ability to have the same thing. Basically launch it and it will become fast enough where you don't have to worry about it before it reaches basically any populated area in all 360 direction. That is a very critical aspect. Like, that is very hard to achieve. You cannot have like a launch site on one end of USA simply because rockets have to go above basically populated area while it's not fast enough nor high enough. Atmosphere will not act as a good shield at that point in time, so they have to only launch some retrogrades one. Most of them have to be launched this way because sea is acting as a buffer. What's a better buffer than the sea itself? Like, let's say you go in middle of Indian Ocean, nothing is there in any direction, or you just below us like equator, you get the benefit that every satellite that you are launching will have a lot of propellant left, because it, instead of like launching then curving then realignment and all that jazz, it just have to simply go launch. And that will save a lot of fuel in your satellite department, because satellite also have to do what we call course correction and station keeping. It will have a lot of reserve propellant. That means the satellite that was supposed to expire in 5 years can easily work there for 6 and 7, simply because it will have the propellant to do so. So fundamentally natural exclusion infinite supply of water and the fact that it's an inherent natural sound suppression system, it makes it ideal, specifically if you want to do it every day. Like right now our launch frequencies are not that high, but we are planning and we are slowly over the years we are moving to a point where rocket launches will happen just as much as plane flights, so in 2020. So sooner or later we have to move to this. Now, how the heck you gonna build something that is as capable, as robust as basically launch platforms that we utilize on land? So, like for a fact that like NASA's crawler that is used to carry Saturn V and carry space shuttle, those were huge Goliath size structure. Is there anything that is strong enough, big enough, bulky enough to handle those sort of loads? Inter oil rigs. These things are huge. Basically, the small ones they go upwards of 5,000 ton. That's like 5,000. Dude, you're a small puppy, bro. You're a small puppy. Big ones can go upwards of 40,000 tons. So these things are huge, and they are built to withstand hail. What does that mean? That simply means they are in the middle of ocean, not connected by any land, and they do not even have any support, any backup, or anything if something bad happens. Now, imagine you are in that scenario and basically tsunami happens. Now, tsunami in the sea is not that dangerous as like the wave height is not that high. If wave height goes up when it crashes to the land, but like still powerful and dangerous, these puppies supposed to handle that without any care. And given the fact that we know they do handle that, why? Because they are old enough. We know, we have experience. They're like, we built it. Okay, now that was the weakness. Okay, we reinforce that. Now it's strong enough. But then we have another issue with tornadoes. These are like, dude, I don't even care. Like the strength of these structures are like kind of mind-boggling, and most humans do not get to appreciate it simply because these are like in the exclusion zone. We do not get to see it. So inherently these things are big, robust, solid, and tested. So that inherently means they are well suited to handle as a rocket. And another bonus aspect, even though they are huge, even though they look permanent, and even sea itself have hard time moving these things, they are mobile. What does that mean? That simply means they can move from point A to point B. Basically, the another company sea launch system that was tried to like basically do the same thing. They did succeed. They did that. It's just finance did not work out in their favor. So they did use that. And the fact was, because these things are designed to be like built in a basically dock and then sent to there, they have the ability to move on their own power. You do not need tugboats. You do not need anything like that. It's just like fuel this puppy up, put people in there, and forget about it. It's just gonna go where it needs to go, be it equator or be it somewhere else. They are mobile and they are self-sufficient. Basically, they never have to worry about water because they use the electricity to run basically RO units, and they have as much water as they need, and they have large fuel tanks, as in like the fuel tanks on these puppies are powerful, basically capable enough that it can keep running for months on end. So they are mobile and self-powered, and we have many decades of experience. That is one thing you cannot buy. Like you can't expect any Tom, Dick, and Harry to know how to build a reusable rocket, because all the people who know have actual experience to building orbital class reusable rockets. They are only work in one company, that is SpaceX. There is no other company. Blue Origin does not have orbital experience. So flat out, that's the one thing. Like that's one experience that you cannot ask anyone else, simply because everybody is limited by that. But in this scenario, there are many companies, there are many engineers, many technicians, many facilities that are specifically built to handle these things. So we know from long-term experience, like we are reaching almost a century of experience, is like how to build this thing, how to make sure these things are strong enough, sturdy enough, that nature is like, bro, okay, we got this, you can't move it. It's almost like Jaeger of a Pacific Rim kind of structure strength we are talking about. So these things, we got the structure side done. Now, how you gonna provide power to it? Because while those oil rigs run on oil itself to power themselves, you can't really do that or financially do it well if you are planning to do with for rocket launches. So the idea is that of course you're gonna have diesel generators as a backup system, but the idea is oil platforms should basically run on wind power. Now, wind power is very well suited simply because they are not as intermittent as like solar, simply because day and night cycle won't be there, and sea has the benefit because of the smooth surface. The wind velocity has less turbulence, so that means even wind velocity is exactly same. Let's say 15 kilometer per hour, 15 kilometer per hour. C gives you more energy simply because it has less turbulence. So fundamentally, all turbines there, they work amazingly. Now, early on, I did not understand why the heck so many European companies and countries, they are pouring so much money into making sea based, and like it's not like they are idiotically overpopulated. They have land shortages or something like that. So why the heck they are building like this? And then it hit me. There's like one awesome advantage they have is shipment. Basically, they can build it. The factories, the big wind farm factories, they are literally situated next to the basically coast area, so they directly ship it to the main thing, main place. Basically, they have to establish here. They will like boat to boat. They don't have to think about anything else. Like we common people do not have an actual understanding of like how big these things are. Like they have to block up a whole road while they are transporting one blade, and they have three blade. And imagine if what will happen if you want to build a farm of these things. Like specifically, it's like a problem become exponentially worse if you are building huge ones. Small ones is as long as anything is small enough where you can fit inside a normal truck into normal road, everything is awesome. The moment you exceed that capacity, which for high efficiency power generation you have to do that, you end up in a problem. So many companies are pouring a lot of money simply by building factories basically on the coastal areas, just like tada, like open the garage door and your ship goes out. That's it, simple. So wind energy is slowly on the background, slowly is being reaching a point where many companies are already experimenting with it, and some are running on it. Basically, right now there are oil platforms that are running on one of those things. So flat out, we also know this. Like these fields are independent from rocket industry, but they are providing the data backbone, the experience, and all that jazz that SpaceX needs to build their future of basically having amazing Starship launch systems on sea. So but there is one caveat. These puppies have to be very far from rocket launches simply because the wind vibration puts the blade under a lot of stress. You really don't want to put a stress of like 120 dB sound off on them from a rocket engine, which you're supposed to be launching almost every day. So fundamentally speaking, they have to be a bit far. Now, that also is it used to be an issue in olden days. We can't put them very far away because how would you transmit the electricity? Now we have high voltage DC to transmit our long distances. So we also have solved that problem. So it's like multiple industry evolved independent of each other, and they have solved all the problems that Elon Musk have to. Basically, Elon Musk at this point in time is just have to buy the like buy component from here, buy component from there, and combine them. Now, what we can expect in the future? Now, SpaceX is known to do try out amazing things, and many times they abandon many things. For example, if you are old enough, there is supposed to be a Falcon 5 which is supposed to be built after Falcon 1. They built Falcon 1, they got the funding from NASA, and they directly jumped to Falcon 9 and let Falcon 5 go. And in early versions of basically Falcon Heavy, they had the idea of plumbing system. Basically, they want to plumb the fuel from the basically side boosters to the center core, or from center core to side boost, whatever the design was, but they have scrapped that. Now it happens like Elon Musk will think of 10-20 things, and then of course with experience, with time, with actual trial and error, we will find out like, okay, this does not work, let's scratch that. So at this point in time, he has already bought this system. Now what he's aiming for, like what is the end goal of this? Not this will be just a prototype. This will be like, okay, we bought this one, let's figure things out, let's solve all the problems, then we'll build custom basically rig from ground up. Now, one thing you have to understand, these things are is designed to deal with oil. Inherently, many of the basically oil reserves have natural gas in them, which has a tendency to go boom. So inherently, they are strong enough, designed to be handle some level of explosion. However, rocket explorer, basically a fully fueled starship with both stages, would be a boom capacity that would be directly measured in nuclear level. It won't be even measured. Nobody would even try to measure it in normal things. It will be a freaking nuclear. Like it will make an explosion in Beirut small. Like that amount of fuel we are talking about, because the fuels are cryogenic, and it's not like kerosene base where it's gonna fall down instantly, and like it does not have the instantaneous combustion effect, because the cryogenic fluids is gonna have very destructive power. So we are talking about some serious power, like basically something that will make Saturn 5 boom events look a joke. Only thing that is comparable enough is N2 rocket booms, but we do not have good footage of that. So the idea is that these things have to be reinforced like hell to in order to withstand hell. And you may be like, okay, but they are expecting rockets to not blow up. That's not how engineering works. Engineering is always designed for the worst case scenario. So you have to do that. And then fueling is the main thing, because rockets drink fuel like there is no tomorrow. So you have to have whole tankers, and because of the insane amount of fuel drain, you can't really expect like okay, I'm gonna fuel these things up and they're gonna keep fueling multiple rockets. Best case scenario, given the volume there, you will be only able to fuel up 2 rockets at best case scenario. Many people did the mathematics with the like, okay, how much the volumes are, like because the booster size has already been built. So worst case scenario, they figure out the volume. It does not have enough volume to hold multiple rockets worth of fuel. And again, you also need support equipment, plumbing, a generator equipments, communication equipments, hundreds of other things also. So it's not like, oh, this whole thing will be a fuel depot, and you really don't want that. So shielding, fuel system. So sooner or later they have to move to a point where we have fuel on site production. How can they achieve that? that? Well, they are testing out the low level process directly on Boca Chica itself. Now, making oxygen, nitrogen, these things, they are child's play. Simply condense the atmosphere. You got this. Don't worry about it. Now, when it comes to methane, thankfully that also is easy right now. If Elon Musk starts to do this, transporting methane would be the cheapest at this point in time, simply because he can just call up. There are many factories that move, factories, what I'm saying, basically oil companies that move LNGs. They connect countries. So these LNGs are like basically backbone right now how Elon Musk is getting the system. But this comes to port sends to factories basically handling facilities sends it to truck goes to Boca Chica. That's how he gets his methane right now. But if he basically builds it on the sea, he can directly dump the fuel here. So that will also make it cheaper, but it does add basically cost and delay. So inherently, sooner or later, they have to reach a point where if they have enough power, they should be able to make fuel on site. Now, how can they do that? Making oxygen is super easy, but what about fuel? You require carbon dioxide, which our earth has more, atmosphere has more than enough. And you need hydrogen. How will you get hydrogen? You have water, you have energy, you have electrolysis. So hydrogen is also available. Then you're gonna make CH4 and 2H2O. Now, we have been doing this in International Space Station. You're like, why the heck International Space Station use that? Well, think of it this way: they get their oxygen from splitting the water. Now that's awesome and all good, but there is a side effect. It releases hydrogen. Now, while hydrogen is non-toxic, awesome, it does have a tendency to go boom, and it is almost unsealable gas. It's like basically you cannot contain it. Sooner or later, it's gonna leak through. So you have to make sure when you are talking about an enclosed space, hydrogen does not reach into a stable, basically people living area. The only way to make sure that never happens is just you bond hydrogen with something else and make it stable, like carbon. So CO2 scrubbers takes out the carbon, provides the carbon dioxide, and hydrogen comes from electrolysis. They mix them match, they both get married together, and they have methane and water. Water is recycled and methane is vented out the space station. Now that's another aspect, because they are sooner or later they want to test these things out in Mars. And because of the fact that we already have a rover on Mars testing this thing out, oxygen part of it, Moxie is already there testing out the oxygen process, and we are assuming that we're going to go there and find a water source one way or the another, because otherwise there is no way to get hydrogen. uh, we should be able to build methane there. But before we can claim that with a guarantee, we have to build this on Earth. So Elon Musk is building small scale prototypes everywhere. We already know for a fact that it can be done in zero G kind of environment by ISS, and now we have to just build something huge. So this will also act as a very good testing ground. So there's a lot of potential there, and given the fact that he no longer have to be like, okay, nobody knows how to do this. It's like if the shipping engineers were like, bro, I got this, I know how to do this. Oil engineers will be like, bro, I've been doing this for like 1980s. I got this. So we have the technology. He's just taking other fields' technology, mixing them together. Now, again, how quickly he can do that? That's the part where Elon Musk is like bit emotional. If he says 4 years, he just add 4 more to it. But he can, but all the things that he's planning to do is far more achievable rather than using flamethrower to light a cigarette, like using BFR to actually transport people. It's like, can you do that? Yes. It's just like, why would you do that? So this was my presentation on basically why SpaceX is buying oil rigs. Hopefully this you have entertained by this video and liked it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.